Welcome to another video by Team Matcom. In this particular video, we will be discussing a question from the chapter Motion in a Straight Line in class 11 physics textbook. The question is, if acceleration of a particle is 6 meter per second square, arrive at an expression for velocity and the position. Find the velocity and the position at t is equal to 4 seconds. Assume that initial velocity and initial position is to be 0. Initial position and initial velocity is to be 0. So basically, this particular question can be done by using the equations of motion or by using the process of integration. For example, if they have given you acceleration, they have given you acceleration. If you integrate acceleration with respect to time, if you do integration with respect to time, you will be getting velocity. If you integrate velocity with respect to time, you will be getting the position of the particle. But that might be a little confusing. The second part of the video, I will explain you how to do that. But you can do this by using the equations of motion. Here they have given that acceleration is equal to 6 meter per second square. Acceleration is equal to 6 meter per second square. They have tell that initial velocity is 0. That means u is equal to 0. Initial position is 0. That means x naught, initial position, is also equal to 0. We need to calculate, come for the expression called the velocity and the position. So we know that according to equations of motion, v is equal to u plus at. We know u is equal to 0 plus acceleration a into t. That means v is equal to at. They have given that acceleration is 6 meter per second square, that is equal to 60. That means equation for velocity is equal to 60. Then you need to find out for position. We know that the position of the particle, x minus x naught. What is the difference? X is the current position, x naught is the initial position. X minus x naught is equal to ut plus half at square. We know that initial position is 0. That means x minus 0 is equal to ut. The value of initial velocity is 0 into t plus half into acceleration value is 6 into t square. 6 and 2 cancel, you will get 3 here. So it will become 3t square. So the position of the particle at the time t is equal to 3t square. So velocity equal to 60. Position of the particle is equal to 3t square. We need to find out velocity of the particle at 4 seconds. That means v of 4 is equal to 6 into 4, that is equal to 24 meter per second. Then x of 4 is equal to, the position of the particle at the 4 second is equal to 3 into 4 square. So 3 into 16 is equal to 48 meter. Equal to 48 meter. How can we do this? By using the concept of integration. Here they are given that acceleration is equal to 6. We know that acceleration is equal to dv by dt equal to 6. That is dv is equal to 6 dt. If you do integration on both sides, or integrating on both sides, integral dv, we know that the velocity changes from initial velocity to final velocity is equal to integral into 6 dt. Time changes from 0 to t, because at a time is equal to 0 to t. You need to understand that integral of dx is equal to x. That means integral of dv will be equal to v with the lower limit of u and upper limit of v. Here we need to find out integral of 6 dt. Since 6 is a constant, you can take it outside. It will become 6 into integral of dt, that is nothing but equal to 60. So 60 with a lower limit of 0 and higher limit of t. Now what you need to do now? You need to apply upper limit minus lower limit. For v, upper limit is v, so v minus lower limit is u. V minus u equal to, when you see here, you can see that here 6 into, here upper limit is t minus lower limit is 0. So that is equal to 60. So what you got? We will be getting v minus u equal to 60. That means v minus u equal to 60. That means v is equal to u plus 60. They told that initial velocity is equal to 0. That means 0 plus 60, nothing but equal to 60. Therefore, equation for velocity will become 60. So we got velocity. Since we got velocity v is equal to 60, velocity is equal to rate of change of displacement, that is dx upon dt equal to 60. If you cross multiply, you will get dx is equal to 60 into, sorry, dx is equal to 60 into dt. If you integrate on both sides, integral dx is equal to integral 60 into dt. Position changes from initial position to final position. Time changes from 0 to t. So integral x naught to xt dx is equal to 6 is a constant, you can take it outside, integral of 0 to t dt. Here you need to understand one thing. Integral of x raised to n dx is equal to n into, sorry, equal to x raised to n plus 1 upon n plus 1, that plus c. But we are applying the limits, there is no need of constant of integration. So integral of t raised to n dt, in the place of n we have n, in the place of t, sorry, in the place of x we have t, that is equal to t raised to n plus 1 upon n plus 1. Therefore, what will happen? Integral dx or integral dt equal to x, or sorry, integral dt equal to t, therefore integral dx is equal to x. So what will you get? You will get x with the lower limit of x naught to xt is equal to 6 into integral t raised to 1. That will become what? T raised to 1 plus 1 upon 1 plus 1. That is equal to 6 into t square divided by 2 with a limit of 0 to t. 6 and 2 will cancel, you will get 3 here. So what will you get? X with the lower limit of x naught to xt, which is equal to 3t square. When you apply the limit, what you will get? Upper limit xt minus x naught is equal to 3 into t square minus 0 square. So nothing but equal to 3t square. So what will you get? You will be getting xt minus x naught is equal to 3t square. We know that initial position of the particle is 0. Therefore, xt is equal to 3t square. So final position of the particle at time t is equal to 3t square. We'll get the same equation. But you may think that it is very difficult to find it like that. But you should understand one thing. If directly they have given you the acceleration without mentioning initial position, final position, something like that, the only way to weigh out will be using the concept of integration. That is why I explained you both the concept. If the first concept is enough for you, you can learn that. If both the concepts are interesting for you, you can learn the both. Hope the video is useful. If you need any clarification, do let us know in the comment section. As a token of gratitude, please like to this particular video, share with your friends, subscribe to our channel. Keep watching, keep learning. Thanks for watching. Bye.